I'm going to talk about pointers. Some C programming tasks are performed more easily with pointers, and other tasks, such as dynamic memory allocation, cannot be performed without using pointers. A pointer is a variable whose value is the address of another variable. For example, direct address of the memory allocation. Like any other variable or constant, you must declare a pointer before using it in order to store any variable address. And you may ask, how to declare a pointer? Easy. You only need a type. In this case, I'm gonna use the integer. This must be a valid C data type, followed by an asterisk. The asterisk is used to declare a pointer. Also is being used to designate a variable as a pointer. And then finally, you need a variable name, which I'm gonna use ib. But how to use pointers? First, we define the variable like we did. Then we assign the address of a variable to a pointer. In this case, I'm gonna define a variable. This is the pointer variable. Then I'm gonna declare another variable, and I'm gonna put a 10 as a value. And finally, we access the value at the address of the variable in the pointer. So we said that IP will be this. And this is done by using the unary operator, the asterisk, that returns the value of the variable located at the address specified by its operand. That means that this value will be returned to this with this condition. As you know, every variable is a memory location, and every memory location has its address defined, which can be accessed by using the ampersand operator, which denote an address in the memory. And this is an example. So now we're gonna to print the results. Print, and it will be the address of bar. And we put ampersand and the bar. Then we'll print the address stored in IP. Well, and we put IP. And finally, we'll print the value of the pointer. Would be asterisk slash asterisk RP. And when we compile and execute the code, it produces the following result. Now, I'm going to talk about pointers and arrays. In C programming, pointers and arrays shares a very close relationship. An array is a data structure that holds a finite sequential collection of similar data type. We use an array in order to store a collection of that similar data type together. To access an array of the element, to access an element of the array, we use the index notation. This index notation starts from 0 and goes up to n-1, where n is the size of the array. Now let's talk about a little bit of the relationship between pointers and arrays. Now we declare an integer array, with the capacity of 10 elements. In order to access to any element of the array, we use the index notation that we said before. So, for example, if we wanted to access to the first element of the array, we should say this. But if we wanted to access to the fifth element of the array, we should use this. Because remember, is n minus 1, where n is the size of the array. So the maximum number of the maximum element of the array will be 9. Now let's talk about a little bit of this in context on pointers. We declare an integer pointer that points at the first element of the array. In C programming, an array exhibits a special behavior. Whenever you refer an array name directly, it behaves a pointer pointing at the first array element, which means this and this are equivalent. This behavior of arrays allows many interesting things to happen. Things such as you can interchangeably use an array and pointers. Also, you can use an array name as a pointer pointing at the first element. Now, I'm gonna give you some examples in context on an array and pointers that are valid too. For example, if you wanted to state that I don't know, if you want to store 10 in the first element of the array, you can put this and say that equals to 10. But if you want now to store another value to the second element of the array, you can also put this to the second and give a value. Also, you can state that the pointer and the array both points to the first element of the array with this statement. And also you can say that the pointer stores, I don't know, 100 to the first element since PTR points at the first element. Now remember, PTR is pointing at the first element of the array. But also you can say the same you can say the same of this, but write it in a different way, like this, and we're saying exactly the same thing, that we stored 100 to the first element of the array. Now I'm going to talk about pointer arithmetic. A pointer in C is an address, which is a numeric value. Therefore, you can perform an arithmetic operation on a pointer just as you can on a numeric value. For example, let's talk about incrementing a pointer. We declare a constant of 4 elements. Then we declare an array and we give the 4 values. Then we declare this variable and the pointer. In this kind of examples, it's better to use pointer in programs instead of arrays because the variable of a pointer can be incremented, unlike the array name, which cannot be incremented because it is a constant pointer. So, in this example, we increment the variable pointer to access each succeeding element of the array, which are this. So then we state the array address in a pointer for 0 and we're gonna print the address bar and then we print the value of bar sorry and we move to the next location and otherwise return 0. Then we compile and execute the code and we are gonna to see these results. The same consideration applies to decrementing a pointer, which decreases the value by the number of bytes of its data type. Now, for example, we're going to decrement, so we said that and we change in here this and also we change this and also we change this. Then we compile and execute the code. We're gonna see these results. Now they are forward. So we can also compare by using pointers. Pointers might be compared by using relational operators such as equals equals. Now we're gonna see an example of comparison by saying this and this. Change the 4 for while the pointer is minor or equal to print the address of bar and the value of bar, and pointing to the previous location. And for this, sorry, my mistake. And when we compile and execute, we're gonna see these results. Now I'm going to talk about heap versus stack. Stack is used for static memory allocation. On the other hand, heap is for dynamic memory allocation. Both are stored in the computer's RAM. Variables allocated on the heap have their memory allocated at the runtime, and accesses this memory it is a bit slower. But the heap size it is only limited by the size of the virtual memory. You can use the stack if you know exactly how much data do you need to allocate before compile time, and also if that it's not too big. You can use heap if you don't know exactly how much data you will need at runtime, or, on the other hand, if you need to allocate a lot of data. In a multi-threaded situation, each thread will have its own completely independent stack, but they will share the heap. So now let's say that some pros and cons of heap and stack. Stack has a very fast access and do not have to explicitly allocated variables. On stack, the space is managed efficiently by the CPU, and the memory will not become fragmented. Stack has only local variables, and also has limit on stack size, and it is always dependent, and the variables cannot be resized. On the other hand, heap has variables that can be accessed globally, do not have limit on memory size. It has relatively slowly access and do not guarantee efficient use of space, and also the memory may become fragmented over the time as blocks of memory are allocated, then will be freed. You must manage your memory. You are in charge of allocating and freeing the variables. And finally, the variables can be resized by using the method realloc.